Topic 4, Objective 2. Use long division to prove the remainder theorem and the factor theorem. So, in the previous video I introduced Topic 4, we're finding roots of polynomials, and we went over the three theorems, the fundamental theorem of algebra, the remainder theorem, and the factor theorem. This whole process again is we're going to use division to see if we can find roots of polynomials and eventually solve these types of polynomials. So the first division we need to use and are going to use is long division. Alright, so I'm going to do an example. There's three processes to this. The first one says to state the number of roots that exist. Then I'm going to divide using long division and state if the divisor is a factor of the given polynomial. Alright, so we're going to use that to prove the factor theorem and then the remainder theorem as well. So the first thing says state the number of roots that exist. That's just the fundamental theorem of algebra, and I just want you to get used to practicing that so when you start to solve these things, you know exactly how many solutions you're looking for. And if you remember, that just means I look for the highest power. The highest power is 4, so I know that there are going to be 4 roots that I'm looking for. Alright? And then it says to divide using long division. Now, the steps I've listed in red are the process I'm going to use for long division. This process is a little tedious, and there are some steps that could lead to making some small mistakes, and so I'll try to make note of that as I'm doing this, and just please be aware of that as you're going along. The main thing about long division is you have to line up everything nice and neatly above and below where I tell you to. So please match your work with mine, and it might just take some practice in doing this, but hopefully by the end of your practice after this video, you'll have the hang of it to reach mastery for this. Now, first step in this, if I was given this problem and it says divide, first I notice that it says the bell. First I notice that it says divide, so that means that I have to set up what's called a long division box. The other thing that clues me that I use long division is that my factor right here, or in this case, please label this the divisor. The leading coefficient of the divisor is not 1. In this case, it's 7. Whenever it's not 1, I have to use long division, alright? And I'll explain that a little bit more with synthetic division after that. Just keep that in mind. When this isn't 1, you have to use long division. So to write in long division format, we're going to go back to, this is step 1, we're going to go back to grade school, I would imagine you learned this. When I draw my long division box, ooh, I didn't leave myself enough room. And inside the division box goes this piece, which is called the dividend. So please label that as well. So I'm going to write 7n to the 4th plus 11n cubed minus 30n squared. Now, if you notice there's a pattern that's developing. It went from the 4th power to the 3rd power to the 2nd power, but then it skips the 1st power and goes immediately to the constant number of 2 in this case. Whenever it jumps like that, I have to use what's called a space holder. I'll put the space holder in red, but that's just to make sure I line up everything correctly as I'm doing this process. Sometimes it's not as needed, but I just want to get in the habit of using that. So that would clue me that I would always have to use this space holder. And so what that looks like, I'm just going to put plus a 0n. That takes place of the power of 1 for those variables, all right? Just so that we can continue lining everything up correctly. And then finally, I'm going to add minus 2 to it. That goes inside the division box. Now the divisor, the factor in question, goes outside. 7n minus 10. Alright? If you notice, like if you were going to divide 90, or like 10 into 90, you would set it up like that. 90 is the dividend, 10 is the divisor. You're going to see how many times 10 goes into 90. Alright? That's the grade school type learning that you've had in your past. And so this is the same process, it's just with polynomials instead. Now, done with the first step. I set it up correctly. Second step, the first term of the polynomial divided by the first term of the factor. Right answer above the like term of the polynomial, above the division box. And this is where I say, please use side math if you need to, okay? I'm going to include my side math down below the steps, but if you can do this in your head, fine. That's awesome, but if you can't, please, I need to see side math before I can offer assistance. All right, so the first term of the polynomial exists right here. The first term of the factor exists right here. So I'm going to do 7n to the fourth divided by 7n. And that equals 7 divided by 7 is 1. N to the fourth divided by n is n cubed. All right, so after I do that math, I get an n cubed. I have to line up the n cubed above the n cubes within the division box, so it goes right above here. So nice and neat above the like term with itself. After that, I did step 2. I wrote the answer above the like term of the polynomial. In this case, it was 11n cubed. Done with step 2. Step 3 says now I'm going to multiply that answer back into the entire factor and write the answers that I get below the like terms of the polynomial. All right? So I'm going to multiply n cubed back into the factor itself. So I'll show that math too. So I have n cubed times 7n minus 10. So it's distribution again. So n cubed times 7n is 7n to the fourth. N cubed times negative 10 is negative 10n cubed. That answer I line up right underneath, because I'm going to subtract eventually, right underneath the like term, 7n to the fourth and negative 10n cubed. So they're happy where they are because they're lined up directly underneath the like terms. From here, that finishes step 3. All right, step 4 then. Step 3, there are some, as long as you remember you have to multiply your answer into both pieces of the factor and then line it up correctly underneath, you should be fine. But that would be the error there, that you don't remember to multiply to both, I would imagine. And then step 4, if I were to read that, I need to cancel out the highest power. In order to cancel anything out, I'm going to subtract these two pieces from the two pieces above. All right, so I'm going to put subtraction. Anytime I use subtraction in long division, I have to put what I'm subtracting in parentheses, because this subtraction piece out here interacts with both terms in there, okay? So after I do that, I'll do the first one, 7n to the fourth minus 7n to the fourth becomes 0. All right, they cancel each other out. That means, and I put that as a hint here, one of the terms should always cancel out if you do this correctly. Now, the other big error that exists in this process happens in step 4. This type of math, all right? I have a positive 11n cubed minus a negative 10n cubed. All right, so minus a negative, whenever that happens, they turn to positive. So the mistake that would make is you didn't distribute that negative into the parentheses, into that term, which means you would get the wrong answer. Because this has to be a positive 21n cubed. 11n cubed minus a negative turns into plus 10n cubed. So 11 plus 10 is 21. All right. I am done with step 4. I've canceled one of the terms out. 7n to the fourth became 0. Now I'm just left with a new polynomial of 21n cubed. Done. Step 5 says to bring down the next term within the polynomial in the division box and repeat the process. The next term is negative 30n squared. All right. At this point, I am done with all the steps. Now I just go back to, I don't have to do step 1 again, I already did that. So I go back to step 2 up here, and I'll do this process in green. The first term of the new polynomial that exists is 21n cubed. All right, we're no longer looking in the division box. It's 21n cubed. I take that divided by still the first term of the factor, and I can show math, side math if I want. 21n cubed divided by 7n. 21 divided by 7 is 3. N cubed divided by n is n squared. All right. That answer goes above the like term within my division box. In this case, it's negative 30n squared. So it's a 3n squared. But please remember that these are polynomials, so you need to add or subtract these pieces from each other. And so because it's a positive 3n, I write plus 3n. All right? 3n squared, sorry. Then from there, if you remember, I'm done with step 2. So I go on to step 3. I multiply the answer I just got with my two factors, two pieces of the factor over here. So it becomes, and I can show that down here, 3n squared times 7n minus 10. I distribute 3n squared. Hopefully I get the same thing as one of the terms, and in this case I do. And then 3n squared times negative 10 is negative 10. I'm sorry, not negative 10, negative 30. Negative 30 n squared. The answer I get after I waterfall this down, or multiply that down, is 21n cubed. And I line it up underneath now, if you remember, write the answer below the like terms of the new polynomial. 21n cubed minus 30n squared. And then I'm done with step 3. On to step 4, I subtract the two pieces from the two pieces above. Remember, put what you're subtracting in parentheses, please. I need to see that in your work. Now, if we read this, 21n cubed minus 21n cubed equals 0. They cancel out. Then, negative 30n cubed minus a negative 30n squared minus a negative 30n squared. Remember, minus a negative turns to positive. Negative 30 plus 30 also, in this case, cancels out. Those terms go away. So I'm done with step 4. Step 5 says to bring down the next term and repeat the process. In this case, this is a unique situation, and this might happen when you're doing this. The next term in my process is also a 0, n. I can't divide anything by 0, right? And so I can't do this process with that 0. So I skip steps 2 through 4, go down to 5 again, bring down the final term, which is negative 2. And in this case, negative 2 divided by 7n doesn't work. You can't put 7 into negative 2. So what happens now is this negative 2, I'm going to write a remainder. The remainder after I divide this factor from that polynomial is negative 2, okay? That's going to tell us something in just a little bit. Now, my complete and final answer, I go back to my top up here. The two terms I did get after I divided out this factor are n cubed plus 3n squared. And then how you write a remainder in this case, and it's the same as elementary school, you're going to write minus, because it's a negative 2, so minus 2 over the original divisor, 7n minus 10. All right? Now, that is part 2 of this process. I divided using long divisions. Part 3 says state if the divisor in question is a factor of the given polynomial. Well, in this case, because it has a remainder, if you remember the factor theorem and the remainder theorem, if the remainder is 0, then it is a factor. If it's not 0, it's not a factor. In this case, the remainder is not 0. The remainder was 2 right here. And so because of that, the factor, let me write it out for you, let me move this down a little bit, of 7n minus 10 is not a factor of the given polynomial. And again, that is because of the remainder of negative 2. And because the factor isn't, the solution of that factor, which in this case would be n equals 10 over 7, isn't a solution of the polynomial either. Alright, go ahead and pause the video and try number 2 on your own. Alright, at this point you should have paused the video and tried number 2 on your own. I have shown all the work, so please take a note. I've shown my side math over here. And then my final answer was p squared plus 10 with a remainder of 0. Because of that, the factor in question, 9p plus 8, is indeed a factor of the polynomial, which means its root of negative 8/9 is a root of the polynomial as well. If you did not get this, please raise your hand and I can check your work.